Welcome to Eureka Math. I'm Mr. Schenkel. This is Algebra Module 1, Lesson 6. Let's get started. Roma says that collecting like terms can be seen as an application of the distributive property. And we have to say if writing x plus x equals 2x is an application of the distributive property. Well, first we need to remember what the distributive property is. So we can write the distributive property in a couple of different ways. A times the quantity B plus C is equal to AB plus AC. Or if we looked at it the other way around, if we started with two terms, AB plus AC, we could find a common factor A and write it as A times the quantity B plus C. So it can go both ways. Either we can distribute a common factor in to a sum, or we can take a common factor out of a sum. Both are the distributive property. So if we wrote x plus x equals 2x, we could also write x plus x as 1x plus 1x, and then we could take out the common factor, let's say x, and we would have x times the quantity 1 plus 1. 1 plus 1 is 2 times the quantity x. So yeah, that's the distributive property. Or we could also look at it in this way. If we wrote 1x plus 1x, we can find the common factor 1 and distribute that out, or factor it out, and we get x plus x. So we take out the common factor 1, and we're left with x plus x. And then 1 times x plus x is 2x. So 1 times 2x is equal to 2x. So distributive property. All right, number 5. Leela is convinced that a plus b squared is equal to a squared plus b squared. And we're going to see if she's right. And we're going to do that by creating an area model. All right, so I've got our grid ready for us. So in order to multiply a plus b times a plus b, we're just going to write that over here. A plus b times a plus b. And then we can find the products for each of the squares inside. So this first one we have a times a, which is a squared. And then a times b, which is ab. And then down here we have b times a, which is ab. And then we have b times b, which is b squared. So our answer here is a squared plus, here's one ab, here's another ab, so that's 2ab, and then plus b squared. So we can see from the picture that Leela is not correct. It's not a squared plus b squared. It's a little more. All right. We can also look at this in this way. Without using the model, we could say a plus b times a plus b, two binomials. And we can multiply those together just by using the distributive property. So a times a, that's a squared. And then a times b, that's a positive ab. And then b times a, that's a positive ab. And b times b, that's a positive b squared. So we get a squared plus 1ab plus 1ab is 2ab plus b squared. And we get the same answer using the distributive property. All right, number 6. Same idea. Let's get ourselves a grid first. Okay, I've got my grid ready. We can do b plus 1 times a plus b plus 1. And then we just find our products for each of the intersecting boxes here. So b times a, that's ab. B times b, that's b squared. And b times 1, that's b. On the bottom, it's 1 times a, that's a. 1 times b, that's b. And 1 times 1, that's 1. And then we've got what we have left, which is b squared, that's this one. And then I see an AB here, so there's a positive AB. And then I see an A, so that's a plus an A. And I see two B's here, so that's 2B. And then lastly, I just see that positive 1. So there it is, b squared plus AB plus A plus 2B plus 1. And we can also show this using the distributive property. So let's take a look at that. We would have A plus B plus 1 times B plus 1. And we can use the distributive property to answer this just by distributing one term into the other parentheses. So I can start here with A and say A times B, well that's AB. And then A times 1, that's 1A, so that's a positive A. All right, and then we move to the next term, this B, and I have to multiply by every term in the other parentheses. So B times B, that's a positive B squared. And then B times 1, that's a positive B. And then lastly, this positive 1 times every term. 1 times B, that's a positive B. And 1 times 1, that's a positive 1. And then I can combine like terms and write it in order. So I have the b squared first, and then followed by the ab, so the positive ab. And then I've got a positive a, that's this one. I have two b's right here, so that's a positive 2b. Those are gone, and then a plus 1. So combining like terms, I get the same thing using the distributive property. So we don't want to have to draw a model every time to be able to solve these. And the distributive property takes care of that for us. All right, number 7, draw a picture to represent the expression a plus b times c plus d times e plus f plus g. Well, we'll just draw the picture and see what it looks like. So let's start here. And I'm just going to split this into 4 equal segments. That'll be good. And then let's label this. So I have got an A plus B times a C plus D. So there's my work so far. Actually, I'm going to move those to the bottom. C plus D down here, same thing. And then I need to multiply by another sum. So in order to do that, I need a third dimension. So I'm just going to draw myself. Hopefully I can get this pretty close. Draw a third dimension here. And we'll be able to see what it looks like, but we're not going to want to try to show where these are. But I have E, F, and G, so I need maybe E and F and then G on the end. So this is going to be E plus F plus G. And now I've got a picture that would work to be able to find the answer to this problem. Each rectangular prism would create a product, and then we would take all of those products and combine like terms if it were possible to do that. But this is what it would look like if we multiply 3 things together. We get a volume or 3-dimensional figure, and each individual each individual rectangular prism like that one would have its own product. So in this case, it would be A times D times this E. And that would be that one segment. And we would do that for all 12 of those segments. But we just needed the picture. There it is. That's lesson 6. I hope that helps. See you again next time.